I am Dr. CVR Padmaja, Associate Professor, Department of CSE, IARE, Hyderabad. I am here to explain the fundamentals of data structures. Before understanding data structures, let us try to understand some basic terminology which will help us in understanding the data structures. Now, what is data? To understand what is data, let us go with the dictionary definition. The quantities, characters, or symbols on which operations can be performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical recording media. That means here quantities, characters, or symbols on which we can perform the operations. So let us take an example and try to understand the meaning of this particular definition. Here in this example, sum is equivalent to a plus b. Here a and 10 both are quantities, nothing but the data. On these two things, we are performing some operations. Here the operation that we perform here is addition. So here the data are a and 10. So sum is equivalent to a plus b. We can store these data values on a magnetic, optical, or mechanical recording media. And that means we can store them on disk or we can print them on printer and so on and so forth. But but in general terminology, data is nothing but collection of raw facts. Data is nothing but collection of raw facts. Now, let us try to understand what is information. Information is the result of analyzing data. That is nothing but processing data. Here, we are collecting the marks in 5 different subjects of a student. The marks obtained in the first subject is 45, second is 23, and so on and so forth. And to announce the result, we need to process this data. Unless and until we process the data, we cannot announce the result. So here, to process the data, we will check the marks obtained in each subject against the minimum marks criteria. In the minimum marks in each subject should be 40. Here, the subject obtained in the marks obtained in first subject is 40, which is 45, which is more than 40, and the marks obtained in second subject is 23. It is not satisfying the minimum criteria marks. So the result of the student will be fail. So we are giving this information basing on the data that is available here. So we are processing this data and we are providing the information after analyzing it. So data is nothing but collection of raw facts and information is the result of analyzing or processing data. Similarly, we can check other variations. Data versus information. Data is collection of raw facts, while information puts those facts into some context. What we have seen in the earlier example. Second variation is while data is raw and unorganized, information is organized. Data on its own is meaningless. When it is analyzed and interpreted, it becomes meaningful information. For example, let us take some word. Let us take this word. Just by seeing this word, we cannot understand anything. This is an example for data. After processing this data, suppose if we apply some operations on this data, then we may get some information. Here, the operations which I apply on this data is reversing. If I reverse the given data, then the word that is obtained here is small. So after processing this data, we are getting some information which is having some meaning. So data on its own is meaningless sometimes, not all the times, but when it's analyzed and interpreted, it becomes meaningful information. And data does not depend on information, but information depends on data. Data typically comes in the form of graphs, numbers, figures, or statistics. Information is typically presented through words, language, thoughts, and ideas. Data is not sufficient for decision making, but you can make decisions based on information. The next thing is data types. To understand data structures further, we need to understand some more terminologies like data types, user defined data types, and abstract data types. First of all, data type. So, what is data type? Data types tells about two things. One is the domain values, and the second one is operations. So, first thing is it defines a certain domain, that is nothing but values. Second one is it defines operations, which operations can be performed on those values. Examples: int, float, boolean, etc. Let us take some example. Suppose if I'm having int a, suppose if I'm having a variable int a, then in this variable I can store values which are of type integers, both positive and negative. I can store 10, -5, some 71, etc. in A. But I cannot store 5.3, -0.9, 10.26, etc. in A, because here A does not support real numbers. It supports only integer values. This data type int specifies what kind of data we can store in A. Similarly, if I'm having float x, then in x I can store real numbers. Some x is equivalent to 2. Here float x is equivalent to 2.5, -0.09, etc. Here x can store real numbers. It can also store integers, but it will store in the form of, if I write float x is equivalent to 5, then it will store it as 5.0. The operations that we can perform on integers. To understand data types, let us take some examples. If I write int a, in a I can store both the positive and negative integers like 5, -15, 25, etc. If I write float x, then I can store 0.25, 2.9, -15.23, etc. into x. So here the data type int specifies what values I can store. So here the data type int specifies what values I can store in A. The data type float specifies what values I can store in X. And coming to the next thing, operations. Here on the data type int, I can perform plus, minus, star, that is for multiplication, division, modulo division, etc. Coming to float, I can perform plus, that is addition, subtraction, multiplication, and division. But I cannot perform modulo division on float values, on float data type. So here the data type specifies what values I can store and what operations I can perform on the data. So this data type is also known as primitive data type. This data type is also known as primitive data type. So, next one is user-defined data type. In user-defined data types, the values and operations are not specified by the language. The user has to specify them. The user has to provide them. To create user-defined data types, primitive data types are also used. Let us see the definitions and examples. For user-defined data types, the values and operations for user-defined data types are not provided in the language itself, but they are specified by the user. Primitive data types are used to create user-defined data types. Examples for user-defined data types are structures, unions, and enumeration. For example, structure. Here, we are creating a user-defined data type, temp, which is having two members. One is of type integer and the other one is a float member. So here we are creating the user-defined data type temp. To this temp data type, if we create some variables, something like temp t1 comma t2, then t1 is having placeholders for two members and t2 is having two placeholders for another two members. When I create a t1 something like this, then I can store an integer value here and a float value here. And it can be referred through t1.a and t1.b. Similarly, I can store another set of values in t2. Here I can write minus 23 and here 0.09. Here this can be retrieved through t2.a and it is t2.b. So here I am storing an integer value and a float value together into a structure variable. Here the structure variable is a user defined data type. It is not there in the primitive data set, but we use primitive data types to create user defined data types. Next one is abstract data types. Abstract data type. The definition of ADT, abstract data type, only mentions what operations are to be performed, but not how these operations will be implemented. It does not specify how data will be organized in memory and what algorithms will be used for implementing the operations. It is called abstract because it gives an implementation independent view. The process of providing only the essentials and hiding the details is known as abstraction. So in the ADT, we'll write the operations, which operations to be performed, but we don't give the implementation details. Abstract data type. The overview of abstract data type is shown in this following figure. The application program interacts to the abstract data type through an interface. Whenever it wants to use the operations of a particular data structure, then it directly uses them through an interface. Suppose there is a stack additive which is implemented using arrays. Okay. Then the application program directly use the functions like push and pop through the interface. The application program doesn't know anything related to the implementation of the stack additive. Later, if I want to upgrade this stack additive from arrays to linked list, then I can implement or I can modify the data stack additive with linked list. Even though I change the implementation from arrays to linked list, the application program doesn't know about that. It doesn't know about the changes of those implementations. It can access the push and pop like earlier. So there are three types: data types, user-defined data types, and abstract data types. Next, data structures. A data structure is a specified format for organizing, processing, retrieving, and storing data. So, data structure is a specialized format. That means it tells about how to store your data, how to process, what operations we can perform on that data, how we can retrieve, and how to organize that. Examples: arrays, stack, queue, trees, and graphs. Why we need data structures? We already have some data types earlier, like primitive data types, user-defined data types, and abstract data types, and so on. So, what is the use of why we need data structures? Suppose I want to store some values. Suppose if I want to store one value, simply I can create a variable and I can store it. If I want to store 10 values, then 10, 20, 30, and so on up to 100. If I want to store these 10 values, then I have to create 10 different variables: A1, A2, A3, A4, etc. A10, which is equivalent to 20, 30, 40. So if I want to store 100 values, means I have to create 100 variables. If I want to access one value, then I have to compare that value. I have to check for the value in the entire list of variables. So declaring variables like this will result in ambiguity and time consuming. So instead of creating variables independently, I can make use of arrays like int a of 10. So in this one, I can store 10 values which is of type integer, whose index starts from 0 to till 9, and the name of this array is A. Now, whenever I want to access a particular element, straight away I can use that index. For example, if I want to access fifth element, I can write A of 4. A of 4 is equal to some 25. So here 0, 1, 2, 3, 4. Here it will place 25. So I can access the elements randomly. Similarly, I can search for an element. Print A of 3. It will try to display the value stored in the fourth location. So it can search the values randomly if I use array, a data structure. So, so instead of declaring the variables, independently, I can go with some data structure which helps me to perform my operations on to instead of declaring variables independently, I can go with the data structure to perform some operations to complete the task. Suppose if I want to redo or undo in any document preparation system, then I'll make use of a stack data structure. So if this is a stack operations, that is insertion into a stack and removal from the stack, will happen from only one end, that is known as top of the stack. To perform redo and undo, we'll make use of stack data structure. So while preparing some document in word processing system, we'll store the operations that we have done onto a stack. For example, I'm writing this statement. This is to test. Instead of writing test, if I write text, then it will store something like this. This is to text. If I want to remove this one, I'll go with the Control Z. That is nothing but undo. So if I type Control Z, then automatically it removes the top element, that is text, from the stack, from the undo stack, and it will place onto the redo stack text. It will remove this one from the stack. Okay. Later I can type some test here. If I want to redo the thing, then if I apply Control Y, automatically the word which is placed in the redo will be inserted onto the top of the stack. That is, it will replace the test into text. So to perform such kind of operations, we need to use some specific data structures. Without those data structures, we cannot complete our task efficiently. So there is a need and necessity to learn data structures as part of computer science curriculum. Now coming to classification of data structures. There are many classifications in data structures. Primarily, the first one is the primitive data structure. In the primitive data structure, the size of the primitive data structure is known and it can store only one data type. Examples of primitive data types are integer, character, boolean, float, double, long, etc., which we discussed in data types. Coming to non-primitive data structures, the non-primitive data structure is a user-defined data structure that can hold multiple values either in continuous or random locations. Examples: structure, stack, queue, etc. So the brief idea of non-primitive data structure is explained through user-defined data types in the earlier slides. So basically, primitive data structures and non-primitive data structures. Primitive data structures are nothing but the primitive data types like int, integer, float, etc. Non-primitive data structure are the user-defined data structures. That is, those are structures, stack, queues, trees, etc. Next, this non-primitive data structure can be further classified into linear data structures and non-linear data structures. Linear data structures, data arranged in sequential order. That is, one element is connected to another in some linear form. Examples, stacks, queues, etc. In sequential order means if it is a queue, so the elements will be placed in some sequential order. Every element, suppose if this is an element, every element will have one predecessor and one successor, except the first one and the last one. Similarly for stack, every element will have one predecessor, exactly one predecessor and one successor, except for the first one and the last one. Coming to nonlinear data structures, data arranged in structured way. Data arranged in structured way. That means it may have one or more predecessors as well as successors. For example, this is a nonlinear data structure. For this node, there is one predecessor and two successors. For this one, two successors. But for this one, there is no predecessor. This is known as the root node. Similarly, if I'm taking some graph, here for this node, it is having three predecessors and three successors. If we see from left to right, if there is one more edge, something like this, then we cannot classify which one is predecessor and which one is successor in this structure. But the data is arranged in some structured way instead of following the sequential format, sequential pattern. So these are nonlinear data structures. Examples for nonlinear data structures are trees and graphs. And based on the time of memory allocation, data structures can be further classified into two types. One is static data structures and the other one is dynamic data structures. So in a static data structure, the memory is fixed and the memory is allocated at compile time. That means maximum size of the memory should be known beforehand. Maximum size of the particular data structure should be known beforehand. And in dynamic data structure, the memory will be allocated at runtime. The maximum size is flexible. Here we can extend the size of the data structure whenever there is a need. But coming to static data structure, we cannot extend or we cannot shrink the size of the data structure. So time at the time of basing on time of memory allocation, we can classify data structures into two things. One is static and the other one is dynamic data structures. So static data structures can be implemented using arrays and dynamic data structures can be implemented using pointers and linked lists. The classification of data structures can understand through this diagram. This is the broad idea of classification of data structures. The initially data structures are classified into two major groups, that is primitive data structures and the other one is non-primitive data structures. Again, non-primitive data structures are classified into linear and non-linear. Linear basing on the memory allocation time, depending on and the time of memory allocation, linear data structures can be further classified into static and dynamic. The static data structures can be implemented through arrays, and dynamic data structures can be implemented through linked list. Static data structures examples arrays, and dynamic data structures can be further classified into linked list, stack, and queue. Nonlinear data structures are trees and graphs. So, in this session, we try to understand the following concepts. The first one is data. Data is nothing but collection of raw facts. And then information. Information is processed data, or the information is nothing but the result of analysis of the given data. And data types. Data types gives two things. One is the domain values and the other one is the operations that we should perform on those values. Data types are also known as primitive data types or primitive data structures. Examples for these things are int, float, character, boolean, etc. User-defined data types. In user-defined data types, the values, the domain values and the operations are not provided by the language. It will be given by the user who creates it. By using user-defined data types, we can create new data types or data structures using the primitive data types. Coming to abstract data types are those things which will provide the functionality of the operations without giving the internal details, how the operations are implemented, using which concept, like through arrays or through pointers. Without giving those details, it tries to provide the functionality of the operations. Data structures. Uh, Here data structures are nothing but giving a specific format for organizing, storing, retrieving and updating the data. Data structures can be classified into various various types basing on the way we arrange them and basing on the time of memory allocation and basing on the structures that we use. So the major classifications of data structures are primitive and non-primitive. Primitive data structures can be further classified into linear and non-linear. Linear data structures are further classified into static and dynamic data structures. Non-linear for static data structures, examples are arrays. For dynamic data structures, the examples are linked lists, linked stacks, and linked queues. And for non-linear data structures, trees and graphs. With this, I'll conclude the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.